Good morning, 9th standard. So, I hope you have all studied your first law of motion. So, your first law of motion we saw about inertia. Inertia means it is a tendency of an object to remain in its state of rest or state of motion unless or until it is disturbed by an external force to change its state. Okay, so that is what we saw in your previous section, that is 3b. We saw what is first law and it is related with your inertia. So inertia, we came across one more quantity with respect to that. It is called as your momentum. So momentum, now I'll give an example before understanding what is momentum is. Consider you're having two different objects. Okay, you're having two different objects but of various mass, A and B. So let the mass of A is 10 kg and the mass of B is 20 kg. Now both of them are running in a velocity, so the velocity be same. So this is also running with 2 meter per second and this is running 2 meter per second. So both are running. If you want to stop, which one will have more force to stop them? Two boys are there, A and B, and the mass of one boy is 10, the mass of second boy is 20, and they are running in a speed or velocity 2 meter per second. He is also running with the velocity 2 meter per second. So the condition is, if I want to stop one, I have to apply more force for B comparing to A. Yes or no? So comparing to A, B requires more force to stop him. If I want to stop him, I have to apply more force to stop him. Why? Because your mass is greater in this case. Your mass is greater in this case. So your momentum formula goes in this way. Momentum is equal to mass into velocity. So we saw the first variation where I'm keeping my velocity as constant and I'm just changing my mass alone. So in this case, I can say momentum of B is greater than momentum of A, or momentum of A is less than momentum of B. So now let us go for the second category. Second category also, again let me take two different boys, let them be C and D. The mass is going to be the same, 10 kg, and for him also it is 10 kg. Now the velocity, he is running with 3 meter per second and this boy is running with 5 meter per second. Therefore, what is your momentum formula? Momentum is equal to mass into velocity. Now you multiply this, his momentum is 30 kg meter per second and this boy's momentum is 50 kg meter per second. So if I want to stop, therefore I require more force to stop this boy comparing to C. So comparing to C, I require more force to stop the boy D. So in that case, I will call momentum of D is greater than C. So now you can understand how do a momentum can vary and what are the ways the momentum depends upon. So you can generalize your momentum depends upon mass and velocity. Why? Because it is a product of mass and velocity. If mass increases, momentum increases, or if velocity increases, momentum increases. In both the cases, your momentum depends upon. So what is your momentum formula? Mass into velocity. To the next one, what will be its unit? What will be its unit? So momentum is equal to m into v. M stands for mass, v stands for velocity. So we will have to write the unit. What is SI unit of mass? It is kg. So now remind from okay, you just recap from your second lesson. The unit of velocity is meter by second. You remember why? What is your velocity formula? Velocity is equal to displacement by time taken. So why I put a arrow? Because velocity is a scalar quantity. Therefore, if velocity is a scalar quantity, here I take my momentum is a scalar quantity because of the product over here. Okay, because of the dot product which is prevailing over here, I will consider my momentum is also a scalar quantity. Now coming back to the unit. So what is my unit? Kg meter by second. kg meter by second. Okay, if you multiply velocity by mass, that quantity is called as your momentum. Okay, now look here, that is what it is given. So your momentum, the linear momentum of the body is the product of its mass and velocity. It's a vector quantity. It can be also represented P is equal to m into v. P is equal to m into v. So my next question is change in momentum. So as I told you before, if you are considering for two objects, you can change mass as well as velocity. Okay, there are two objects like A and B, two objects like C and D. In that case, you can fix one and you can change the other. Can you get me? You can fix one and you can change the other. So there is an object called as A and B. Or we'll go in this way. A, B, C, D. So the masses. So for this both I'm going to fix my mass as 10, and for this both my mass is 20. So I can change my mass. Next one is my velocity. So for this it is 2 and 2, and for this one it is 3 and 5. I can change my velocity. But if I'm going to take for one single mass, one single object, let me consider for A. So for A, mass is 10, velocity is 2. So after 5 minutes, I can change my velocity. Yes or no? I can run faster. But can I change my mass here? You cannot change your mass. Similarly, you consider for C. What is the mass of C? 20. What is the velocity? It is 3. Now I can increase my speed or I can decrease my speed, but I cannot increase my mass. So whenever you consider for a single object or for a single person, or you just consider for a car or a truck, you cannot change the mass of the truck. Therefore the change in momentum can be written as delta m into v. So the symbol, something which is looking like a triangle, it is called as your delta. This is called as your delta. Delta means it is denoted a small change. Okay, it's your like mathematical signs you will learn. In the same manner, delta means it is a very small change. So here I'm going to find a small change in my momentum. So delta p is equal to delta m into v. Now you are going to run. So for first 5 minutes you are running in a speed of 30 meter per second, and after 5 minutes you're going to increase your speed, let it be 50 meter per second. So you are going to do this, but in all these process, is it possible for you to change your mass? So for first 5 minutes I'm going to be 30 kg, and for next 5 minutes I'm going to be 35 kg. Is it possible? It is not possible. Therefore your delta p can be written as m delta v, which means m is a constant factor. M is a constant factor which does not change. A mass of an object is a constant factor and it will never change. Only delta v changes, that is the way in which its speeds can be changed. The speed of the object can be changed. A truck which is initially rest and it starts moving, therefore there is a change in its velocity, but the mass of the truck will never change. If it's going to weigh 500 kg, it is going to be the same. The mass of the truck will never change. So this is how you are supposed to write your change in momentum. What is the right expression for change in momentum? Delta p is equal to m delta v. Delta p is equal to m into delta v. Okay, this is not the right expression. So this expression suggests both of them will vary. Mass as well as velocity can vary. That is wrong. Okay, this you cannot write. Only this way you can write them. So can you see here? So delta p is equal to m delta v. So this is for your normal objects which is having more mass. But now comes a condition where the mass is going to be very minute, where you will have very less mass, that is your atomic particles. So if you take atomic particles, the mass will be less, but the velocity in which they are traveling will be quite high, because your electrons, protons will have the velocity which is nearly equal to your speed of light, because speed of light is the fastest speed which is not achievable by any object. So in that case, if you take in electrons or protons and if you go deeply into them in their atomic scale, you will find though the mass is very light, the velocity is comparable or nearer to the speed of light. In that case, you cannot write this formula. Okay, you cannot go for this formula. Instead, you have to write a different formula for them, where you have a different expression for your mass. So that particular equation is given: m is equal to m naught into square root of 1 minus v by c square. Okay, so m naught determines when the object is in rest. So whenever the object is in rest, its velocity will become 0. So obviously this equation gets valid of p is equal to delta p is equal to m delta v, but you will use m equal to m naught in some other cases when the mass is not going to remain as a constant. So as of now, you just learn delta p is equal to m delta v. So how do we represent change in momentum? So that is our next topic. So using this, we will arrive at a new quantity. Okay, so using the change in momentum, you will arrive in a new quantity. So now first write the formula. What is delta p, that is change in momentum, is equal to m into delta v. So delta v means there is a change in its velocity. So what are the two types of velocity? You know, one is initial velocity and the other one is final velocity. So whenever there is a change in velocity, which means there is a, all these are taking place with respect to some time. Okay, yeah. So initial means when the time is 2 seconds, final means when the time is 10 seconds. So within this time interval only the velocity is changing. So therefore I can write my delta p is equal to m into change in velocity. Change in velocity formula, how we used to write: v minus u divided by t. Remember, use this equation from your second chapter. We have learned this in your second chapter, because change in velocity means there are two velocities, final velocity and initial velocity, and they change with respect to the given time. Therefore v minus u divided by t. So what is this quantity? Yeah, what is this quantity? V minus u by t, it is nothing but your acceleration. So delta p will give my acceleration. So the change in momentum is nothing but mass into acceleration. Change in momentum is called as mass into acceleration. So can you see here? So the rate of change in momentum is nothing but mass into acceleration. So the law clearly states that this change of momentum in a given time is nothing but the force. Is nothing but what? Force. Now come back to the same example which we started initially. We just saw an object A whose mass is 10 and it is initially moving with velocity 2 meter per second. Yes or no? So an object A is here whose mass is 10. This is your mass. Initial velocity, let it be 2 meter per second. Suddenly the velocity is changing, by which it is becoming 5 meter per second in a time of 2 seconds. All these are happening. So when do the velocity will change? Until you apply an external force. Only if you push an object or if you accelerate your car, if you give an acceleration, if you apply an external force, there will be a change in its velocity. There will be a change in its velocity. Therefore, using that concept, I can write delta p is equal to m into delta v. So all these are taking place in a given time. Therefore, delta p by t and mv by t is nothing but f is equal to m into a. F is equal to m into a. So this is how we got your second equation. So the change in momentum is called as your force, and the mass into change in velocity. Okay, so change in velocity is nothing but force into acceleration. So change in momentum, so delta p into delta mv can be written as force into m into a. So change in momentum is force, change in velocity is acceleration. So this is how we got our next equation, that is f is equal to m into a. So the law goes in this method. When a force acts on a body, the rate of change in momentum is equal to the product of the mass of the body and the acceleration produced in that due to that force. The acceleration produced in that due to that force. So this is how we obtain this particular equation. So with respect to this, let us see the next one, Newton's second law of motion. That is the derivation of the law F is equal to m into a. So Newton's second law of motion will qualitatively speak about your force. Okay, how the force is going to